In this movie, we're going to learn about another important concept in encryption and in password security, which is the concept of salt. Before we talk about salt, we first need to talk about rainbow tables, because that's the main reason that we need salt. Now imagine that a hacker gets a hold of our database, but we've been smart and we encrypted our database. Let's say we encrypted it using the SHA-1 algorithm. So those are now all encrypted and you cannot tell what the plaintext password was. But the hacker can take one of those values and then have a little program that just runs and tries every single value possible. Every word in the dictionary, every combination of letters and numbers, tries everything possible looking for a result of the SHA-1 hashing algorithm that matches your result. And if he can generate a result that matches, then he will know what the input was. He'll know what the original password was. So you may be thinking, well, that's going to take a long time, right? I mean, to try every single word, every single password, computers are fast, but that's still going to take a very long time. But what if we pre-compute those values? What if we go ahead and try every combination and store the result of that in a database or in a table so that we can look it up? So for example, if our password is secret, we encrypt it with SHA-1, and then the result that we store in our database is E5E9FA1B, and so on. Well, if the hacker ahead of time has created these rainbow tables, he will have tried secret, passed it into the SHA-1 hash, and will have gotten the same result. So he'll look at our database and he'll see, E5E9FA1, let me look that up in my rainbow tables. That corresponds to secret. And voila, just like that, he can use these pre-computed tables to immediately know what the password is. That's the reason why we use salt. Salt is going to add additional data to the password before encryption. So for example, a very simple salt would be to do something like this. Put salt on the password. So now it's not just the password anymore. It has some other string with it as well. Now, in order to know the password, means you also have to know the salt string. A rainbow table still could be generated that had the string put salt on the something, but even if you got that, even if you figured out what that was, you wouldn't necessarily know what the password was. So rainbow tables could be used, but they'd be almost impossibly large. But we don't have to stop there. We can go even further. We can also create our salt by using strings that are unique to each user. And that way, just because you figure out the salt or the password for one user, you haven't necessarily compromised another user because theirs is different. A very simple example of this would just be to use their username. Now, that's not a great candidate really because username is probably also stored in the database, but still, it would be something that would be varied in our salt and would give us a different result. So now, knowing the password requires knowing the salt string and knowing that user string, and also knowing how it's used in the salt as well. So rainbow tables are still impossibly large, but now each user's salt is unique too. So even if you were able to crack one user, you still would have to start all over again for another user. And we can go even further by having random salt. That is, we can create our salt by using pseudo-random strings, not by using something that's predictable like the username. So we have intrand or time. Those are PHP functions that return things that are pseudo-random. They're not 100% random, but pretty close. And then we can generate our string like put salt on the password at, and then we can have the time appended to it. And that would then give us a different result. So now knowing the password is going to require knowing what the random string is. Rainbow tables become completely useless as each user's hash is almost random, almost unique. Now there's one problem with this, which is that now we've generated this fantastic salt, but we need to be able to reuse that salt in the future, right? We need to have it available for our purposes so when a user comes back to the site and wants to log in, we can apply that same salt to the password to be able to regenerate the hash that matches what's in the database. So we'll need to store our salt in the database. So when using user data for salt, and user data could change, or when using random salt, we store the salt in the database, not the password, just the salt by itself, just so that we have it available to us. It's also a good practice to hash the salt so that it also will not be in plain text, just so that there's no way that it gives away anything about where it came from or how it was generated. Now, if all that seems kind of complicated, let me walk you through the actual PHP steps that we're going to use to do it. This is sort of a simple version of what we're going to create. We're going to generate our salt, and our salt is going to use mtrandom to generate a random string, and then we'll pass that into unique ID, which is a function that will generate a unique ID and make sure that it's unique. True helps make sure that it's extra secure, and we'll take that whole thing and we'll hash it using the MD5 algorithm so that it's encrypted and not in plain text, and we can't tell where it came from originally. So that's how we'll get our salt. And then we'll take our salt and we'll append it to a format string. We'll take the two together, format and salt, and that's what we'll pass into the crypt method. In the first example I showed you, I just called it salt, but the salt actually includes the format at the beginning. So it's debatable whether you actually call that format part of the salt or not. I'm going to make it clearer by just saying it's the format and the salt, and calling the salt just the string that goes after it. So hopefully that explains to you the concept behind salt, why we need it, and how we're going to use it in our crypt function. Let's try writing the code for it in the next movie.